I want to add one objective to creative design, which is sustainability. We know that today we are more and more concerned about the future of the entire planet, and so we need to make the best possible use of the resources that we have. And is this constraint killing creativity, or can you work with a constraint? Now, the next speaker is one of the best living examples of the fact that you can make the best use of available resources and be creative at the same time. Suppose you have the telephone network and you want to use that for broadband access to the internet. Is there a solution there? Yes, that is ADSL, and that was invented by John Cioffi. John, you have the floor now.
Thank you very much for that kind introduction. And let me maybe a little less historical and try to actually pose a solution to some of the problems that were suggested, innovation and creativity, and how do we continue to do that, specifically within the area of telecommunications. So the title here, Software-Defined Access Networks. You've heard of software-defined networks, I think many of you have. But I'm going to focus on the access part of that, and suggest some thoughts that may help with some of the specific problems that were brought up just a minute ago by our speaker, Prince Constantine. Let me first just tell you what I mean by access networks, my outline here, and then investment. And many of the previous speakers talking about the importance of actually getting things into use. And of course, they have to be financially viable in order to enter use. Getting that involved in your innovation is often very important to the ultimate use. And then finally, competition and innovation and the effect that it has on that investment, specifically, again, for access networks. So what is an access network? I have the internet cloud up here, but and of course, it's just transformed life for all of us. But the access networks are connections to things out there. They could be wired, can be wireless, increasingly wireless, and thanks to Marconi and his early work, many of those these days. An increasing number of things, and you have to get in and out to and from the internet. And it could be people. It could also be things. We're hearing more and more about the Internet of Things as we proceed. And how big is this, and what is its effect on telecom? So here I put a little pie chart for you to see. The actual access network, roughly at about 35 euros a month. I'm using euros here since we're in Europe as the currency. It does work out to about 1 trillion euros a year worldwide that is actually spent on access charges. About 3/4 of that is in the area of mobile. There's about 2 billion active mobile users. If you actually look at numbers, you'll find numbers like 6 billion or so, but the number of active subscriptions is about 2 billion. So that works out to about 750 billion euros a year. And fixed line, maybe smaller, 25%, but still a very large number. 250 billion euros are spent worldwide on access network connections. So very important segment of the industry, and this is more than half of all the total revenue in telecom, the other part being, of course, the business revenue, or what's called enterprise. And what you're seeing on the mobile part, very important trend, it's unlicensed spectrum, particular, but Wi-Fi, almost approaching 50% of the devices that are going in the field, these active mobile users, have a Wi-Fi alternative. And many of you are very familiar with that. You may switch to Wi-Fi on your smartphone whenever that may be convenient for you to do. There's a lot of reasons. You think of them individually. Maybe it works better, or you perceive it as being cheaper, or a number of other reasons for that. And there is an explosion of that type of thing going on, particularly in the residence or the home, if you like. Typically have a wired connection into some kind of gateway, but increasing use via Wi-Fi connections to all of the devices, or the things, if you will. Sometimes they're connected to a human being. Sometimes they may not be. If you actually look, and this number comes from the United States, which is actually ahead in the number of connected devices per residence now, but the rest of the world rapidly rising too. The numbers from some of the big service providers already in the United States are 12 connected devices per fixed line home. Very large number. So if we took that 250 billion euros, if you will, or the 700 million connections you saw on the last slide, multiply it by 10, okay, or by 25 is what is predicted here in a few years, and you're up into over 10 billion connections that are actually flowing just as shown here. Big part of access. So huge numbers involved here. And even more important, perhaps, is there are now more connected devices in homes than there are people on the face of the earth, and headed upwards from that. Now, if you actually look at the breakdown, this data comes from Cisco, the breakdown between the different segments of data in Internet use. The dark area down at the bottom there is fixed Wi-Fi, and the lighter blue area is fixed. And then the mobile data, okay, surprisingly, while that's growing, all this perspective on mobile data and how big it is. It's actually, that's the licensed spectrum. But the biggest part is the part that's being offloaded to Wi-Fi. And often that's because of video. Okay, people doing over-the-top video, that uses a lot of data, and so forth. Another interesting graph, and I have to kind of explain it to you a little bit. This is an interesting one we found. You can find it on the internet, but it basically shows you the growth of the iPad and the iPhone since inception. Okay, so for the iPhone, of course, it's 2007 would be year zero, and the iPad, I believe, was 2009 in terms of its introduction. And the red part is the tablet. Okay, this is a device being used in a home. So it's eclipsing the smartphone in terms of the amount of use, or the number of users, the amount of sales that are going on in that. So this is giving you an idea of that offloading to Wi-Fi. Even more important here down at the bottom of the screen, if you look at all the tablets that were sold, okay, recently, you see that 80% of them were sold without even having a 3G or a 4G connection on them. And if you look at that 20% that were sold with that connection, actually only 5% of them are active. So the vast majority of these devices are actually working on Wi-Fi, not on the licensed spectrum. They're working on the unlicensed spectrum. So all interesting data. Data rates for 2G to 4G are shown here, going up to a gigabit per second. Give you some idea of how fast the 2G, 3G, and 4G are entering the world population in use. Obviously 2G going down, but still a substantial segment. 3G kind of still going up, and 4G, of course, growing. But let's look at it. Even if you had a gigabit per second in 4G, and you have some reasonable region, and we have all these 10 devices, 20 devices per household, if you were trying to use licensed spectrum for that, you get about 100 kilobits per second each if they're all active. They're all trying to view video, maybe for several minutes to an hour at a time. There's just not enough spectrum to really get you the speed that you want on that. And the solution, of course, is with cellular technology. We like to think of it as smaller and smaller cells, which I'm showing here. But ultimately, as you head that direction, Wi-Fi is one of the alternatives that you could have for a small cell. Again, on licensed spectrum. Now, if you have Wi-Fi and you have all those small cells, you need to have a backhaul technology, if you will, of the Wi-Fi to the internet, and that's going to be a wire from the center of the cell, wherever it is in most cases. And this gives you some of the numbers worldwide on what those wires are. In terms of using existing infrastructure, obviously that's cheaper. And the number of DSL connections on a worldwide basis right now is approaching 500 million. And then you see fiber and cable at smaller numbers. So that gives you an idea, access networks, okay? So that sets the stage a little bit. How do we get to this stage, and how much does it cost to get there? Well, a typical case that you see, most telcos, it really does boil down to this simple case worldwide. If you look at 35 euros a month, there's about 8 euros in profit in there, after taxes and expenses and other things. If you're running the system fairly well, that's about what you're going to be able to see. And then if you cumulatively plot that profit month to month to month, you'll see that about 3 years out, you cross 300 euros in terms of your return. And a 3-year return on access investment is about as good as it gets. Unless you're getting a very wealthy government, there aren't too many of those left in the world today, to invest in something. 3 years is a pretty reasonable, maybe the limit in terms of investment. So if it costs more than 300 euros to add a customer, it's probably not worth it to a telco service provider, an application provider, whoever is doing that. So that's the limit at about 8 euros a month in terms of profit. Recent examples, okay? Well, you see that AT&T in the United States on an iPhone sale typically subsidizes about $400. Well, that's pretty close to 300 euros, okay? There's another $100 they charge a customer, and they're expecting that they're going to get that money back over the next 3 years, and then beyond that, it becomes profit to them. If you look at Deutsche Telekom, big announcement last December 2012, that they're going to spend 300 euros per customer for 100 megabits, what's called VDSL connection, very similar to ADSL. This is some fiber that goes part of the way to the customer. That's a viable investment. It's 20 million customers, or 6 billion euros that they're going to spend on that. They also reported the reason they didn't run fiber to everyone's home is the real cost of that is 4,000 euros per customer when it's averaged across the network. So that would have been 80 billion euros, and they couldn't afford to do that. Maybe on a different note, Sky is kind of a competitive provider. They actually provide broadband service in the UK in addition to satellite TV. They get a little higher profit because they include their satellite TV in a package, but they paid about 400 pounds per customer. It's a little bit more than 300 euros to purchase O2's assets in the UK. So this figure of a few hundred euros per customer, that's what it's worth to the telcos in terms of access networks. And that's where all the money's coming from in telecom is those customers. So now let's look at this investment at a little more detail. Infrastructure investment. Who can afford this? Okay. Well, typically it's big telcos. Okay. You see an announcement last November from AT&T in the United States. Now, they typically spend about $20 billion a year on capital. This is acquiring, improving their network. They announced they were going to spend an additional $14 billion to increase their customer connections. $8 billion of that is going for about 20 million LTE customers. Again, the $400 per customer number. Another $6 billion is going for 50 to 100 megabit vectored DSLs. Again, roughly about 300 per customer. And I mentioned the Deutsche Telekom announcement earlier. Now, these are big incumbent providers. Okay, lots of money, lots of customers coming from that. They can afford that. If you look at LLUs, local loop unbundles, as they call them here in Europe, competitive providers, the Sky purchase was about 200 million for half a million customers. So that's the level that they can invest at. And there's this thing in Europe, that phrase that's becoming common with the regulators and telcos, Highlander investment. And this goes back to a television program that I guess was popular in Europe. It's called The Highlander, where there's these guys, these deities fighting one another. Only one survives, okay, because that one finishes the show, basically. So a Highlander investment is whoever invests first, okay, gets control of the network, and everyone else has to go through them. That's what's happening, and that's some of the principles that are evolving, and were just actually stated in the previous talk. Mrs. Crow's, in fact, driving some of the approach to that. But, okay, they have the money to invest, and that's trying to be encouraged. But where does the innovation come from? We've heard repeatedly today. It probably doesn't come from the large companies. They've been government-owned for a long time, or at least government-regulated. They've developed a bureaucracy over time. Very, very difficult, even with the best of intent of all of their employees, to innovate. Innovation typically comes from smaller companies, venture capital funding, universities, so forth. It may be good recent examples of that are Google and Facebook. Maybe those are bigger companies today, but it's only been 10, 15 years. Give them some time, perhaps they'll become bureaucracies at some point also. But they've driven the demand for these networks. So you want to encourage that too. So the regulators stuck in the middle of this in their quandary, so they'd like to encourage both. They'd like to encourage investment in those networks, build out higher speeds, do what's possible, but also to encourage the innovation in the networks. So let me talk about that a little bit, the competition and innovation. I'll leave you with my conclusion and thought here in a few slides. There was a concept that was introduced in the mid-90s, unbundling, which basically the idea here was to try to encourage competition. And what happened was the owners of the facilities, in this case I started with wireline facilities, had to lease their, in this case, copper wires to alternative service providers and essentially break the connection to the old network and put a new network in parallel with that and rent space in the telco central office and connect to the phone lines, basically, if you will. And this is what you call unbundled access. And, of course, at the end of that connection is the Wi-Fi within the home. Similarly, you could think of the different license bands in mobile spectrum being a form of trying to encourage competition, essentially providing separate facilities for each of supplier A and B. Okay, very important here, different hardware for the different service providers. Okay, so now move ahead 20 years or so, but who, and of course, who invests in the fiber as either the antennas get closer or the copper lines get shorter and the speeds go up on this? So that's going to be the large incumbent telcos who can afford that type of investment. So now what they've decided to do in this case is to encourage what's called bitstream unbundling. For fixed line here in Europe, they call it VULA, virtual unbundled local access. And for wireless, you can think of it as an MVNO who's using the existing spectral facilities. And a competitive provider sits on top of that and rents a bitstream. And in fact, with software-defined networks, what's happening is those competitive providers can in fact create services in software instead of hardware on top of that. But it all stops at the access equipment. And it doesn't get actually to the access into the home. And actually, if you look at the statistics, this is where all the problems are occurring, okay, in terms of transmission. When you're looking on your iPad, watching video or some other iPad device, and it's stopping, or it's taking too long, or whatever, chances are it's happening on that copper facility or it's happening in the Wi-Fi part. It's not happening in the rest of the network. So this leaves the competitive provider with no way to differentiate. Okay, they're still dependent on the investment that's made in the facilities by the incumbent. So here's my solution or suggestion on this. The incumbents manage the network typically through SNMP connections to their access network, be it wired or wired line. And this is kind of the situation that you see today. But what you need, and in fact is now possible, I'll show you some examples, is kind of a software-defined access network. It takes that SDN concept and extends it all the way out to the consumer, involving apps on the smartphones and the tablets, involving application interfaces in the gateways, but all on the consumer side. And this is, again, where all the problems are occurring. Now, it is possible to do a bitstream lease, but when you can manage those facilities, now the over-the-tops can differentiate their services completely, as if they owned it. And it's all done in software instead of the old hardware unbundling that was done 20 years ago. So an example, let's say, if some people look at this and say, well, how can you do this without the telco having to basically bless it? Well, let me give you an example. Some of you in this room may have broadband service, and they've sold you up to 20 megabits per second, but who actually gets that? You might be getting 6 megabits per second on it. So there's extra bandwidth there that you purchase, but you're not getting. If you practice this type of software-defined access network, it's possible in many cases to get double, quadruple the speeds that are possible by doing this type of management. So now let's say you're getting 12 megabits instead of 6. They already sold you 20. They should stick by their promise, right? But this allows the over-the-top to increase the speeds. And since most of the impairments are noise within the customer's residence, whether it's a Wi-Fi interfering with other Wi-Fis, or it's the copper lines picking up interference from all types of appliances or other types of devices, if you can reduce that, you increase the speed. So here's an example, and I'm going to play a video here, but let me explain it before I hit the play button on it, if I'm going to be able to do that with my mouse here. But the one on the left is going to use this technique, and what's going to happen is a noise interference is going to be introduced in the home environment. Two identical phone lines. These are real lines, okay, they're just brought into the same place. It's actually done on AT&T lines in California without any knowledge of AT&T of what's going on in the system, where the home noises are being managed to improve the quality. And if I'm able to hit my play button, what you'll see is this software-defined network essentially over the top fixes the problem. So hopefully, are we getting the video here? Let me try. Is it now moving? There you go. So you can actually even hear the audio on this. So there's no problem initially. But what, for example, can happen is another Wi-Fi system turns on, your neighbor's Wi-Fi, whatever, starts colliding with yours. No box, and so you can see both sides go bad here. And this is the kind of stuff that makes you drop the service, right? You get angry when you're seeing this on your pad or elsewhere. But with the software-defined system, completely over the top, and you see eventually it's figured it out. And it's cleaned up the left side. You're hearing the audio from that, where the right side continues to be garbage. So whether you're Facebook or Netflix or any other over-the-top app, that's the kind of difference you can make. All done without the service provider actually knowing about it. Because as long as they don't do deep packet inspection and throw off the improvement commands, and why would they want to do that? They're getting better service. You've got an improvement. Another example of the improvement from this in the UK from Ofcom, which is the regulator. Here's a quarterly reported results on the number of problems they have. And B-Sky-B is one of the more progressive groups in the UK. They are actually using techniques like this already. And you can see there the purple curve on the left, the last 3 years. Their problem reports, 0 means no problems, and 1 means everybody's complaining on this scale from Ofcom, as reported by the regulator, are consistently going down. None of the other service providers have that particular capability. Some more data, actually, from the UK as well, on connections, broadband connections that are having problems. It's about half and half between the copper and the Wi-Fi right now as to what's actually causing the issue on the line. So it gives you, and here's another example just taken from a connection when it's running. It's supposed to be a 54 megabit Wi-Fi connection. Obviously, you never quite get the 54 megabits because of throughput, so you get about 40 megabits. Then suddenly another Wi-Fi turns on. It gets trashed in terms of its speed. It goes way down to a few megabits per second. And then the system turns on, begins to learn. Excuse me, I think the University of Bologna wants me to join their Wi-Fi network here, so let me get back to the presentation if we can. There we go. And gradually that system is learning over the top again and improving. Here's some more examples. These are lines actually in the United States, connections. These are copper connections over on the left-hand side without the software-defined access network, and then removing the noises in the home through basically MIMO techniques, a bunch of antennas, if you will, to remove noise from the phone lines. We've seen that in wireless. It's possible in wireline. And speeds, quadrupling, quintupling, so forth. Over the existing speeds. So then my conclusion here in this whole area of software-defined access networks, Marconi could be very proud here. We can unleash the unlicensed spectrum with Wi-Fi and, of course, the backhauling of that. There's 500 megahertz of Wi-Fi spectrum. That's a huge amount that's out there. And if you can use these techniques, basically anyone can compete and differentiate their service. So instead of having hardware unbundling, as we saw 20 years ago, my suggestion is that go to software unbundling. So thank you very much for your time.